Remember this video? Soon, the United States will have its first 5G broadcast. Well, as of September 13th, 2023, WWOO-LD transitioned over to 5G broadcast. I had the opportunity to talk with the business development manager and vice president of operations at XGen, the company behind this development of 5G broadcast.
I'm John Schwartz. I'm the business development manager here.
Okay.
Andrew is the brains of the operation as it pertains to XGen.
Gotcha.
So he's the best person to definitely talk to about any questions you have about what we're working on and what, kind of like our scope that we're allowed to tell you, because, we have a bunch of like NDAs in place, with various partners and whatnot. So I'll let you take over the call, Dylan, and fire away on what's on your mind.
Just to give some background about me, I'm a 19-year-old electrical engineering student at Florida International University in Miami, Florida. That's where I am now. So I'm very passionate about over-the-air broadcasting, especially the radio part of electrical engineering. One of the questions that I think came to my mind first and foremost is with just how many devices are even going to be supporting 5G broadcast. So I think one of the hallmarks of 5G broadcast compared to ATSC 3.0 is the fact that 5G broadcast capabilities are technically already in so many consumer devices that are already on the market now, where with ATSC 3.0, there just isn't that consumer product, availability like there is with 5G broadcast, hypothetically, if software turned them on. So what do you see that landscape being like in the next year or two with 5G broadcast tuning capabilities and decoding these broadcasts over the air?
That's a very tricky question. So just to let you know, everything that we're doing right now, we're implementing every single time there's a new change. So this is very well in the development stages. Even though we're able to get it work in a very rough development stage, is speaking very loudly compared to the other technology, which is 3.0. And so with that said, yes, all the devices that support 4G, LTE, or 5G, pretty much that has anything from FE and BMS enabled, that this will work. Now, the only thing that is blocking it, which is, this is publicly known, is that the filters are completely blocked from those frequencies.
Yes. For
that to happen, it's just a firmware update. But now, since like you're a lot younger, back in the early 2000s, we used to get cellular chip modem updates over the air. Like you can even back in the day, you used to be able to call the, 10-digit code to where you can manually update your modem chip. That's not the case now with modern smartphones. I think they stopped that probably when the iPhone 7 or iPhone 8 came out. So that was a while ago. So they stopped that because there's pretty much everyone has a smartphone now, to where it takes so much to update those chips, especially since cellular works 1-to-1 at a time. And it's not even multicast, it's all unicast. And so that takes a lot of time to update all the chips, to where eventually there's the Qualcomm phone manufacturer and carrier, they pretty much agreed to where if there's an update that needs to be done, it's in the new chip. You go buy a new phone. If we look at today's schedule, we're in October. Sales have decreased and slowed down because of the pandemic. So usually we get new phones in November. Now it's in October. Everyone's a month early because they announced everything in September. So the phones already came out. And if you look at OPP today, they are the first ones to do an article about 108 band being open. That's broadcasting frequencies meeting the cellular spectrum, and to where now we can kind of work together through the new set of standards that 3GPP just released. So not going to give you a direct answer, but with all that said, are these phones coming out this month going to have that update?
No.
But since the standard is in now, and if we look at current patterns, that if something were to get approved at least 8 months before the new set of phones get manufactured, that update makes it. So does that mean next year's phone might get it? That's a high possibility.
Okay.
So that's my way of answering your question.
Gotcha. I want to touch base on what you said about the fact that it is essentially a 4G LTE waveform. So a lot of people think, when they hear that 5G bit of it, this is actually using the 4G LTE waveform, and that's one of the actually key components between this and a technology like ATSC 3.0, which can send data closer to the Shannon limit, and it's just more spectrally efficient. What are your concerns of that spectral efficiency with 5G broadcast in comparison to like ATSC 3.0?
So I can only say this because everything is so particular and technical. So 4G LTE, yes, today. That doesn't necessarily mean next week, because 4G and 5G are marketing terms. They're not technical terms, but they are to a certain aspect. But for at least on the mobile side, we always talk about the releases. So for me as a technical person, I really don't care what 4G and 5G is. I care about the technical specs of, right now what we're running is 4G LTE broadcast is released 14/16. 15 got skipped because of the pandemic, and everything had to get delayed because of the pandemic. So if you want to know what 5G is, that's 17, 18, 19, but 19 also starts 6G. So again, the names of everything doesn't matter. It's the releases that matter, because it's whatever's inside those specs, those features, what make things. So it's kind of weird. Like, it's so much easier to say this is an LTE technology than 4G or 5G, because that doesn't, like, that can mean so many things. Just like when we say 5G, it's like, what are we actually talking about? Is that Internet of Things? Is that Wi-Fi? Is that cellular? Is that broadcast?
Is it millimeter wave? Is it low band?
Exactly. So it's more of like, when we did our test, yeah, it's LTE. But where we're headed in the very near future, yeah, that's very new standards. And yeah, it can communicate to real 5G equipment. So, but it's just what's currently out right now is 14/16 is widely available, just because we kind of stopped our world from developing and working for the past 3 years.
Obviously, we know that the television broadcast band has been shrinking. And at one point, we had RF channels 2 through 83 way back then. And now we're stuck with 2 through 36. And a part of the radio spectrum that a lot of broadcasters don't like to utilize is the low and high VHF bands. Do you ever see 5G broadcast being implemented in that low VHF and high VHF band of the broadcast spectrum?
That I couldn't tell you, because at this point, it's still so new. We have our experimental license, and we have to do whatever the FCC wants. And we don't take baby steps. We move inch by inch. So it's smaller than baby steps, especially since this is so new. So like, questions like that is going to, there's a wide range of questions like that. We can answer that right now, because this is like, this is Apple and Microsoft being developed for the first time in the 80s. No one really saw what all that happened. But now in today's age, you're seeing this happen in real life. This is still super brand new, even for the company that had this going for 2 years, even did it with older tech, and now they're partnered up with us. But it's like, we're barely 10-15% into this before it gets official. So it's going to be a long time until you get that answer.
So I watched your video about that test when you guys first launched WWOO-LD with the test transmission, which was awesome. I really liked that video. My question is, when you had like France 24 up on the screen, what codecs were you using?
That is an HLS low latency live feed from France 24. So they're using the Apple version of HLS, because people do get confused. So if I explain this and you already know, I apologize. That, there's HLS and then there's HLS low latency. I guess HLS LL. Low latency, that's Apple. So it's their way of trying to, because Apple likes being the middle person. Like, they have ProRes for all their digital files. Well, now they want to be the middle control of the codec, because they don't want Google to have it. So besides all that, through the encoder that we're able to use, we were able to pick the profile that we want out of the HLS. So we just picked a 2K resolution, so we can downgrade it a little bit to make it even more sharper, because even if we took the 1080p profile out of it, I didn't want to experience any lost packets. So I actually delayed the feed by half of a second. So with all that said, I used H.264. I could have done H.265, but I didn't want to bog down the server to do that. And it was 30 frames per second, and their feed comes in PAL, so I had to convert it to NTSC. So that's going to delay it even more and make even more drop packets. Didn't want that to happen. So just because I'm also a filmmaker and also work in IT, I know how all that stuff works, and I know how to manipulate the media for that. So and then I just did AC3, which is standard for broadcast anyways. I could do Adobe AAC, but I mean, wasn't necessary, and it's the same file size, same coding process, so it's like there's really no difference. But I also manually compressed it from, usually when you go H.264 with the HLS stream, it wants to do 2 megabits. I was able to compress it all the way down to 1.1 megabit.
Do you plan on implementing broadcast streams with VVC video or AV1 video to try to maximize that RF channel with as many streams as possible in the future?
Oh yeah, I mean, especially now since like most because also we got to play a different game than full power, because low power doesn't make that much money. So we have to be very careful of what devices we pick from. So most cost-effective devices that lets us do multiple subchannels, depending if you're doing that through the encoder or some like pass-through device that talks to the digital exciter. What's most cost-effective for the most subchannels we can do is 8. But usually EAS, your cap system, will take one of those channels, so it's 7. But then according to how you cater to some of the FCC rules about showing your legal ID or your call ID, that might take another one. So in reality, it's probably somewhere between 6 and 8 channels most, or subchannels, so you can have up to, that many streams. But it depends on, where you're at, what the FCC requires you to do, how your infrastructure is set up. So it depends on so many factors. So I would say maximum 6 to 8, but I mean, we want to do as much as possible because that's how LPTV makes some of its money.
Well, and that's the great thing about, and like was shown in your video, it was being sent to an app, so you could have that decoding capabilities directly inside of that app. If you had a new next-gen codec, you could implement that right into your application.
Yep.
ATSC 3.0 has super high SNRs and super low SNRs, like 36 decibels could be one implementation, and then like -5, almost -6 decibels. What is the equivalent for 5G broadcasting? What's the lowest SNR possible, if you know?
That's very hard to say because it all depends on the area that you're at and how you're transmitting. So like I can give you an answer based on us going to Boston, but then again, in Boston has, we're very close to an airport. There's multiple shipyards. And then Boston has very high terrain. So it's like, I can give you an answer for where we were about almost 3 miles away when we did our demo, but that necessarily doesn't mean the same thing for when you're direct line of sight, half through the altitude of it, or being on the ground and being blocked by buildings. So it's like, that's such a mixed bag of tricks. I can't really give you a direct answer because even if you were to do it as a regular white sheet to get a proper answer inside of a lab, again, it's if you don't have a proper isolated facility to properly test that, you're not going to get a real answer because it's all going to be theoretical. So I can't answer that except for a real live demo, and I can give you an answer off of that demo, but also then again, at this point, I can't even give an answer based on the readings that we did because that has to be submitted to the FCC first.
Can 5G broadcast be sent below the noise floor at all with like a negative SNR? Do you know if that's possible to send like TV channels super robustly? Because that's one of the hallmarks of ATSC 3.0 is that it can.
But also, it also depends because on a full power tower, it's a lot harder. But on a low power tower for ATSC 3.0, yeah, that's more doable because the altitude difference. But with 5G, I want to say yes and no. I mean, even our signal to noise ratio was awful when we did our demo, but it still just worked though. Like that's the other thing is like these behaviors for 5G, because like we have a 3.0 station that's also in Boston.
Isn't it WCRN?
Yep.
Yep.
And so working on that for over a year now, it's like, I don't know, it's just that the behaviors and the readings are just so completely different, but the same at the same time. Even if I were to set up, have two transmitters and I was able to change out the filter really quickly, and had both running at the same time, but in two different setups, even if they had the same reading, because the same antenna, same placement and everything,
Yeah.
the fact that ATSC 3.0 will take on a low or negative signal to noise ratio, it will take over a minute to populate into the device. 5G, it just works. Is
that like a hardware issue with the newest equipment, or is that like the technology itself? Because I know there's like,
well, for 5G, it's everything, and also it's all in sync because it's the same equipment talking to each other. Where ATSC 3.0, all the equipment inside the chain of your broadcasting station doesn't necessarily mean that it's communicating directly with the receiver. Even though, like, say, the top chip right now is made by Sony for ATSC 3.0,
yeah,
and you have a data box feeding that information and collecting your tuner, making sure that it's all working together. And then once that gets sent down and go to the receiver using the same Sony chip, doesn't necessarily mean that they really speak the same language. There's just a huge disconnect. But also, then again, let me grab something. Can't show you the actual name of this box, but so this is a 3.0 box, and so
yeah,
I've been testing this this is our first responder box. So this is a special device for first responders to get video feed and communicate with each other a lot better than their two-way radio. It takes so much power, and even though 3.0 is meant for mobile and you can drive, we're able to get a feed and collect data going 75 miles per hour on Highway 95. This will work, but then at a certain point, like it gets into an old buffering habit to where it just completely drops and then just completely disintegrates all the data. It falls apart. Even if you have a file error correction carousel working, it doesn't communicate. It completely it's like, say, me and you both speak three languages, but we don't speak the third one that much. And then 5 years goes by, we completely had to speak that third language. That's kind of how this works. It doesn't know how to switch brains properly. Where like a cell phone, these things are overpowered. So of course these things are just going to work like that. And also the fact that there's 4 to 8 antennas in each phone.
Yeah.
Compared to the one antenna that's going to be inside this. Yeah, this is, just specking it out and just pushing power through this. This is, this is one of the top receiver boxes for 3.0. This beats this by like 20 times.
Yeah, and it was really fascinating in your demo to see just how fast that phone was able to tune into that broadcast and start decoding it. It was, compared to what ATSC 3.0 is like right now, the HD home run, I know it's over the local area network, but still it sits there for like a good 3 or 4 seconds, and then it brings up the video and audio. But in your demo, it was like super instantaneous.
Well, let's think about this. Like if you build a custom computer, this is Intel Pentium Core Duo 2 back from 2012.
Yeah.
This has 16 cores.
Yeah, exactly.
High performance and low performance.
Yeah.
This runs at 1.4 gigahertz. This runs over 5 gigahertz. And this box is half the price of this, but there's more of these.
Yep, exactly.
You have a whole totally different rabbit hole and a different scenario why this over this, because, everyone has this now. Even in, third world countries, everyone has this.
And I think that's kind of getting into the future of broadcast and what I wanted to talk to you guys about, which is I strongly believe that the future of broadcast isn't just linear TV feeds. It's all sorts of other data that could be sent out. One of the examples that I was thinking of was just like something as simple as like a weather app. People in a large geographical area could just have all of this weather data just downloaded to them. Why would you need a weather app? with an internet connection when all this data is really redundant and being sent out to everybody. So that's like an application, and there's countless other ones that I've outlined in my videos, but I think that's going forward a more beneficial use for the broadcast spectrum, because linear TV is not what it used to be. I think we can all kind of agree with that. I'm just curious if you guys have any intentions of starting to kind of look into that avenue for data casting and other use.
We're all about data casting for first responders. Anything for emergencies or supporting any kind of major infrastructure within our country, we can heavily support. Because the way I tell people is, our towers are it's our country's Wi-Fi antennas. Yeah, there's a bunch of cellular towers out there, but that's kind of like having a home router. Like, those aren't that great, and it takes so many to cover a certain area, where broadcasting towers, like, oh, there's like 200 cellular towers right there. Why is that? Boom, broadcast. Okay, we covered the whole entire area. But also, it's like, with all that said, I tell people this is kind of like a new .com boom, and also it's kind of like, like what John reminds me is kind of like playing Watch Dogs or Cyberpunk 2077. It's like, what can't you do with this technology? It's like, you can do so much. Like, like one big thing that people want to do with ATSC 3.0 is distant learning. This is also a distant learning box, and it's like, you can do so much with this. You can offload so much stuff. Like, you can be really creative with all this, even reinventing TV. Like, the filmmaker in me wants to utilize this to, how do I bring back linear TV? And does that be linear? It can, I kind of want to call it dynamic TV, because I have a bunch of ideas of how to revive this, especially since people are now leaving streaming because it's too expensive and they're going to broadcasting.
Yeah. And that's a great point. I think just consumer awareness about over-the-air TV in general, and just all the possibilities of the one-to-many model and broadcasting is just so important. I don't think many people realize how much data could actually be sent to them without an active internet connection. I mean, just describing, how like a server on my local area network would work, people would think, oh, well, you're streaming that. Well, no, it's not using the internet. It's still getting me the data, but it's not even utilizing that internet connection. And it's kind of a thought process that a lot of people don't, fully understand.
And here's the other crazy thing. When we get to a further, or once we're able to adapt newer releases from the 3GPP into this, is that it's now not just one to many. It's broadcast and multicast at the same time.
Yeah, that's a great point. There is some inefficiencies of broadcast, just like how there's inefficiencies of the unicast system. So definitely multicast is important. Do you think we'll see 5G set-top boxes or 5G broadcast set-top boxes in the near future at all? Or do you think this will just be a cell phone momentum?
Oh, no. The way I see it is, we're human beings. We deserve options.
Okay. That's awesome. Yeah.
Yeah. So I'll just leave it at that, because that might happen
with Best Buy and see like a 5G, it's got the NEXTGEN TV logo, and then underneath it says 5G broadcast. Or
we'll see what happens in the near future.
Okay. That sounds like a good future to me.
I mean, and it's doable because, it already exists.
Yeah. Hey, look, I think if both technologies live in harmony, then that'll be a great future. I mean, broadcast,
that's what we want.
Yeah.
We want everything to work, and Qualcomm has a white paper that will be released to the public very soon of how 5G and 3.0 can coexist.
Yeah, and I think some companies are starting to go against that, but it's definitely, in my opinion, important for both to thrive. So that's awesome.
Yeah, we care about making things that work and proving that it works, and how do we move forward with that with that mindset. We don't really invest heavily into all these technologies. It's just we support our nonprofit and our members, that we want to show what options do we have. How do they survive? How do we how do we support the public? Because we still have to follow the main golden rule that all broadcasters have to follow around the world.
Yes.
One broadcasting feed, an emergency system. Anything outside of that it's not broadcast and it's not for the people. Like these were made for entertainment and for safety during World War I, 2 times. So it's like, these are crucial parts of our infrastructure that it's for everyone.
Yeah, it's nice to see broadcasters that actually care and actually understand the fact that they are using a license, like they were granted a license by the federal government. It is a privilege to have a license. You're using the public airwaves, and anything you do with the public airwaves should be absolutely 100% in the public benefit. So I appreciate what you just said. I think that's great. And I hope more companies follow what you guys are doing, because that's some important stuff.
If you take a look at our nonprofit, LPTVBA, which has majority of the low power station operators in it, everyone within our membership stand by that message. Like, we're here to support people, and whatever technology works to bring data, we get to do more, especially with a lot of climate crises happening around the world.
Yes.
I want to see stuff like this work with drones. I want to give real bird's eye view feed from a drone, send it to the guys on the ground. They're going to have a better perspective of what's going on. They can treat the situation a lot better because they know more that's going on. Because the helicopters can't stay up and watch that, because then they get damaged, and also that costs too much. They're risking their lives, and also they rather be delivering water, sawdust, or whatever they're using to take out that fire anyway. So why not just risk a $300 drone that can take a hit?
Yeah, on the public benefit side, I know you guys are a 3.0 broadcaster along with the 5G, but my question is, and I know this is a hot topic right now, do you guys ever see yourselves implementing DRM encryption on your ATSC 3.0 signals or on your 5G broadcast signal?
No, because there's no point. This is for everyone. It's public television, and also all you're really doing is you're causing more issues. Like, and also I'm a gamer. We know the DRM issues.
Yeah. Yeah, I mean, I think we're just seeing now with the ADTH box that just came out, there's an internet connection required just to get the decryption to work. So I think as just a public like emergency alerting situation, I think as a whole, that is just very bad. And I hope that the ATSC addresses this. And I'm appreciative of broadcasters like you guys and all the work that you do to make sure that, the airwaves stay DRM free as it should be.
We're definitely going to hear more about that at NAB 2024 in Vegas. Not so much New York, because New York is mostly like, oh, here's our refresh of all our equipment. It's really not where the industry is going. So like, I wouldn't hold my breath for any real big updates for NAB New York. Sometimes it happens for whatever reason. I mean, things are kind of off schedule now because of the pandemic, but most likely March to April is where we're going to start hearing all those big updates.
Because I know another big thing too is LG just announced that they're now taking out ATSC 3.0 tuning capabilities in their 2024 TVs.
Yep, second biggest TV manufacturer out there. So if the second one decide to do it, I mean, Sony's third, and Sony's the one making all the 3.0 chips.
The HD Home Run uses a Sony chip, if I'm not mistaken. Yeah, They're big in the 3.0 space.
And we use HD Home Run. It's I think only one of those is a certified box, but most of the HD Home Run equipment is non-official ATSC 3.0 certified. But they work better. They work better than all the certified boxes.
Yeah. Yeah, well, we've been seeing that a lot now with people saying that, they can't get the DRM encryption channels to pop up, or, they're having other issues. So I really appreciate the effort and time that you put into this. Thank you for reaching out.
Absolutely. And it's been a pleasure talking to you. And Dylan, I don't think this will be the last time we talk. So hopefully we'll be giving you some more news sooner rather than later. But all right, Dylan, well, it's been a pleasure. Thank you so much for organizing this. And we'll be talking again very soon.
Awesome. Thank you, guys.
Take it easy, Dylan.
If you like this video, consider subscribing and liking the video. Follow Western New York Over the Air on Instagram, Twitter, and Threads at WNY Over the Air. Like Western New York Over the Air on Facebook at facebook.com/WNY Over the Air. Support the channel on Patreon at patreon.com/WNY Over the Air. And check out WNYOvertheair.com for live band scans, cord cutting tips, and much more.